Hey guys, we got some exciting stuff today. So we'll be going through lab number 4, and we'll be talking about user-defined functions. And kind of just the main purpose of this assignment is just understanding how to define functions, and we're going to incorporate some of this other fundamental stuff we've learned in order to do so. So let's get started with our prompt analysis. So here we're being asked to write a program whose input is a character and a string. Okay, so again, right away, we're analyzing our prompt and we should be thinking, okay, we have these inputs. Okay, we have a character and a string, that's what we're expecting. And our output is going to indicate the number of times the character appears in the string. So we might already be having some ideas, but let's continue working through this. So the output should include the input character and use the plural form, and if the number of times the character appears is not exactly 1. So we might be thinking, hey, this is very similar to something we've already done, right? In lab 2, exact change, we made the exact same kind of decision structure, so we can reuse that here. And another important thing to think about here, excuse me, is that case matters, right? A lowercase n is not the same as an uppercase n. So this will make our program a bit easier to write. Cool. So we have to ask ourselves before we go about solving this problem, are we making any assumptions on the input? Typically, when we advance a little bit further into programming, we will require that the user enter the correct input, like a character and a string, and we will reprompt them if they don't. But here we're kind of just trusting them, and so it's important to keep that in mind as we go throughout this solution. So the program must define and call the following function that takes the input string and characters as parameters and returns the number of times the input character appears in the input string, right? So we have this function prototype right here. And I think it's worth spending some time to look at this header. So we have our return type here, right? So we're returning an integer number of times, an integer number of uh, times that the character appears in the string. And so our name, using this Pascal case style um, identifier definition, is calc number of characters, pretty descriptive and yet not too long. And then as parameters, we're going to pass it a string for user string, right? This is the string that we're searching uh, searching for the number of occurrences of this user char, right? So cool. Now, let's talk a little bit about where functions are typically defined and how we go about writing functions and kind of decomposing code in a very readable way. So typically, from what I've seen in C++, a lot of programmers tend to define their functions above the main, so like somewhere like right here. So we can throw a prototype, or we can define our function here if we'd like. And it's also worth mentioning that we don't have to define our function where we declare it. So if I wanted to just put in the function header and then a semicolon, this is what's called a function prototype. I've been throwing that term around, but this is what it actually is. We could say, okay, this is what the function looks like, and if we wanted, we could define it down here, and C++ would be okay with that. We could do this and some of that, and say, okay, this is where my code is, right? But to keep things simple, we will just define it where we declare it. Just wanted to mention that so you know that is a possibility. Okay, so how do we approach this problem? So when we're dealing with functions, there are many types of return types. Any data type you can have can be returned by a function. In this case, we're just using an integer. So if we're returning something in our function, which we don't have to, by the way. There's also a void return type, which does not return anything. But if we are returning something, like we are in this case, then we will want to initialize our return data, right? So that's something we're going to want to do. So we're going to be returning an integer for the number of occurrences that this string appears in, or I'm sorry, this character appears in the user string. So initialize return data. Okay, so now what's the next step? So one more note actually before we continue building this outline. So I wanted to talk about how we have this Pascal case. It's just it's the name of the style, like this convention for making identifiers, right? Where every single first word has a capital letter. What I see more commonly is camel case, where the first letter is lowercase, and then the start of every word after that is uppercase. But we have been told to define it with this style, so that's how we will do it. There's also snake case, which is more typically used in Python, which looks like this. The way we style our identifiers are very context dependent. So we can just go here and yeah, so basically we just want to keep in mind that while our identifiers are mostly preference, there are also conventions for when we would use different styles. But for now, like I said, we will keep the original style, Pascal case. Okay, awesome. So we want to initialize our return data, and then we want to calculate uh, calculate the num of characters. So calculate the number of occurrences um, in user string, or more specifically, the number of occurrences of user char in user string. Okay, and then after we're done doing that, we just want to return num of occurrences. Okay, cool. So this is nice, right? So we'll have this function that will kind of do one isolated task, and it'll make the code in our main function look a lot cleaner. And when we have more complex functionality and a much larger program, it'll be very, very important to use lots of functions so that the code in our main is legible. So now, what do we want to do in our main function, right? So we're told that we have these inputs. We have the character and the string. So we'll need data to store these inputs. So I want to declare all data. And again, I will just reiterate that I'm doing this just for the sake of our outline, and typically it is an unnecessary comment to say something like, oh, declaring data, because it's obvious that you're doing that. So we're going to want to declare all data, so our input variables, and then we're also going to have a variable to store the number of occurrences that our character appears in our user string. So that will be in there as well. And then, as you may be getting used to by now, we're going to want to read in this data. And then after that, we want to we're going to call our function, right? So this is an important piece of this exercise. We're going to call our user-defined function, and since it has a return type, we can just assign the function call to one of these variables that we've declared. And then finally, we want to output our data. And this will involve a decision-making structure, just like we had in, so just an if statement, just like we had in lab number 2. Awesome. So let's jump right into it. So when we're looking at this, we have an outline, right? So we know what we want to do. So how is it that we actually do this, right? So again, whenever you're approaching a problem, you want to think, what tools do I have? Like, what do I know? What can I use? This sort of thing. So far, we know how to make basic calculations in C++. We know how to um, use branching to our advantage, and we know how to use looping, right? So all of this stuff is going to come in handy for us. So the problem is asking us to count the number of occurrences of a character in the string. So what is the most effective tool to do that? Right? So if we need to consider every single character, then we'll probably need to loop over the entire string. And we can incorporate branching into this because we need to be checking if any given character inside the user string matches the user character that we have. So we want to initialize our return data, right? So you can use whatever identifier you want. I just like this one, so we'll say, okay, our occurrences is going to be initialized to 0. And why do we initialize it to 0 instead of some other number? Or why do we initialize it at all? if you recall from lab last Thursday, if we just declare it like this and don't assign it with any initial data, then it will probably have an absurdly large random number just from wherever, just from the memory that resides at that location before we decided to allocate it for this variable. So we're going to initialize it to 0. And obviously, we don't want to initialize it to some higher or lower number because by default, there's 0 occurrences in the string until we determine otherwise through our looping process. Okay. So we've already stated that we want to loop over the string, right? So that's going to be incorporated into this calculation. So we want to loop over the length of the entire string. So if we want to do this, we have to ask ourselves when we're constructing loops, where do we want to start our iteration and where do we want to end, right? So the lower boundary you can use either 0 or 1 as discussed in the looping lab, but whichever one you choose will depend on how, or rather, the looping boundary will depend on where you initialize your counter. So the way that I did it was like this, right? So I said that, okay, we're going to start at 0, and we're going to iterate until I is strictly less than string, iterate while I is strictly less than string length, and then we're going to increment our counter, right? So string length is not yet defined. So what we could do is we could just say, okay, let's have user string dot length, or I'm sorry, not dot length, dot size. But for reasons you will learn later, this is actually inefficient because you're making a function call for each iteration of the loop. So what we will do is we will just pull this out of the loop. And it seems like it doesn't make a difference, but it actually speeds up our code marginally when we use larger data sets. So it's good to get into this habit now. We figured out what our looping header should look like, right? We've determined, okay, we need to do something with every single character inside of the string. And if we start at position 0, let's make a little example string here. Let's say we're checking character B in the string Bob, right? So if we look through this, then position 0 is right here, right? This is position 0. And the string length is 1, 2, 3. So we're going to start at 0, and then we're going to go until while I is less than string length, right? So 0 is less than 3, so we go up. 1 is less than 3, so we go up. 2 is less than 3, so we go up. And then we'll say, okay, well 3 is not less than 3, so then we're not going to consider this next character, and therefore we're not going to enter the loop body after we're done iterating over our string. Okay, cool. So what is it we want to do? Again, I might be sounding repetitive, but we want to go through and check each character and see how many times the user char appears. So we want to compare the user char with each character of the user string. So what we could do is we could use the index of any given character in user string and compare that with the user character. So we could say, okay, let's say if, so we want to see if they're equal, we want to increment the number of occurrences, right? Because we're just trying to count something. We're just trying to count the number of characters in the string. So if the user string at index I is equal to the user char, then we will increment our number of occurrences. Let's not forget our semicolons. Awesome. Right, okay, cool. So it looks like we've kind of written our function. This looks good, right? But when we're defining functions ourselves, we have to remember if we have this return type, if it is not void, then we need to actually return our data. So let's do that. So just use the return keyword, whatever data you're returning, so occurrences, and then a semicolon. Nice. Okay, cool. So it looks like our function is taken care of. Now what do we want to do in main? So we're going to need to read in these two pieces of data so that we could pass it to the function. And we're also going to need a variable to store the occurrences that we're going to return with our function call. So we will need 3 variables for that. We're going to want our user char, we're going to want our user string, and then we will want our number of occurrences. right? So then we want to read in the data. So far we haven't really prompted the user for data as of yet, but this is actually a really good practice. So we kind of know what we expect from our program, and this is a learning exercise, so we just kind of read it in. But what we should really be doing is asking. We should be asking. Um, we should be prompting the user for their input. Now, since this is auto-graded, it might give us output issues if we try to do it this way, but I will just leave it in here for demonstrational or for instructional purposes. So yeah, so we're just saying, okay, enter a character followed by a phrase to count the number of occurrences of the character in that phrase. It's a little bit wordy, but it gets the point across. If you don't know what this program does, when you get given this prompt, then you know what to enter in, and it does a good job at kind of ensuring that we're going to receive the correct input. Okay, awesome. So we prompt the user for the data, and then we're going to actually read the data. So remember, we just want to read in two variables. And something I haven't mentioned yet is that cin removes the white space in between inputs, right? So if we have this long string, like in the example where it says Z today is Monday, so it's going to read in with cin the first character. So since this is the first character, this immediately gets stored, and this is going to be left in the input buffer. And so we're using another cin, so it will just continue until it reaches the first character, so it will just truncate this white space here. And then since we're reading in a string, it will just read this all the way until the next white space. I'm sorry, until the next new line. Awesome. So with that out of the way, we have read in our data, and now we want to call our function. So you guys have called quite a few functions before, we just haven't called our own user-defined functions. So our function has a return type, so we're going to want to use the function to we're going to want to assign the value returned by the function to our occurrences variable, right? So they say occurrences is equal to the value returned by this function, right? So the way we call this is we just use the identifier, and then you don't specify type when you pass in arguments to your function, right? So when you're calling the function, these are arguments, and when you're defining the function, these are parameters. So a subtle distinction there, but it will become more clear as you continue working with this stuff. So now we just want to display our output, right? So this is kind of the easy part. So we just want to say, okay, if you look at the sample output, we want to output our number of occurrences, which we've just calculated and assigned to a variable, and then followed by a space, and then the user char, and then we'll decide whether or not we want to output this apostrophe s based on whether or not there is a plural number of characters, right? So no matter what, we're going to do that first part, right? So we're always going to output the number of occurrences followed by a space and then the user character. And then we're going to decide if we want to pluralize. And this will happen more often than not. We're going to say, okay, well, if the number of occurrences is not equal to 1, then we will pluralize the string. Else, we just leave it the way it is, right? So just as I said, we're just going to output this apostrophe s. Oops, did not mean to delete that. If there is exactly one, or I'm sorry, if there is not exactly one occurrence of the character within the string. And that is all there is to it. So yeah, guys, I hope this has been helpful. Functions are absolutely vital in any programming language. You can't just slap all your code in main, otherwise there would be no way to scale to larger programs. So yeah, I will see you guys next time.